Hi, welcome to Nomi's Academy. In this video, we are going to be looking at cycle theorems, and then we are going to solve problems under Theorem 5. In the previous video, we defined or we state Theorem 5 to be the opposite angles of a cyclic quadrilateral sum up to 180 degrees. So we are going to be using that idea to solve lots of problems in today's video. So let's pick the first example. Example 1. Find the marked angles in the diagram. Okay, we have a cycle. Okay, so this particular angle is 50 degrees. Why this angle is called x? This angle is y. Why this is 80 degrees. Okay, now we are asked to find the marked angles, which are x and y. Now let's start. So we can say that to find x plus 50 degrees sum up to 180 degrees. And then what is the idea behind this? That is Theorem 5, which states that the opposite angles of a cyclic quadrilateral. A cyclic quadrilateral is a four-sided shape which is inscribed in a cycle, or whose four vertices touch the circumference of a cycle. So these opposite angles sum up to 180 degrees. So we make the statement. The statement is, call it cyclic quad. We use the short form quadrilateral. So whenever you see cyclic quad, it means that these two opposite angles sum up to 180 degrees. So to find x, write x equal to 180 degrees. Then we move plus 50 to the other side. It becomes minus 50 degrees. So x is equal to 130 degrees. So the size of this angle is 130 degrees. Now to find y, we do the same thing. Y plus 80 sum up to 180 degrees because the two opposite angles are set to sum up to 180 according to Theorem 5. So we have y plus 80 degrees equal to 180 degrees. Okay, to find y, the statement is cyclic quad. So cyclic quadrilateral. So y is equal to 180 degrees minus 80 degrees. So the size of angle y is 100 degrees. Okay, 100 degrees. Now let's pick another example. Example 2. Find the marked angles. Okay, let's have the diagram. Okay, let's take it gently. All right, so this point is the center of the cycle. So we have lines this way. We have another. So this particular angle is y. This is x. And then here is 50 degrees. Okay, so this is center of the cycle. Q, P, angle at P, S, and R, angle at R. So we're asked to find the marked angle. The marked angles are x and y. So we have to find x and y. So let's clean this side. Okay, so let's proceed. Solution. So firstly, let's find angle at P. Angle at P. So we agree that the angles QRS plus QPS sum up to 180 degrees, and the reason for that is cyclic quadrilateral. So this particular angle QRS is 50 degrees plus QPS is X equal to 180 degrees. So to find X, we have X to be 180 degrees minus 50 degrees. So X is equal to 130 degrees. 130 degrees. So the size of X is 130 degrees. Now to find Y, to find angle at that point, that's the obtuse angle QOS. So that will be QOX obtuse QOS, which is Y, is 2 times of angle QRS. Okay, so you remember the theorem? That's theorem 2. It says that an angle at the center equal to twice the angle at the circumference. Okay, so now let's go and do the simple substitution. Let's clean this other side. Okay, so to do the substitution, and remember QOX is Y, so we have Y equal to 2 multiplied by QRS is 50 degrees. So Y, the value of Y is 100 degrees. That is the solution to the problem. So let's go to another example. Example 3. Example 3 says that find the marked angle. So we have the diagram. Okay, this is the center of the cycle. Okay, here we have B, A, D, and C. So this angle here is Y, and this angle is X. So we have this particular angle to be 52 degrees. So we are asked to find the marked angle, which is X and Y. All right, now let's solve that. Let's solve the problem. Let me clean the other side of the board. First and foremost, the first thing I need to do here, I need to consider the diagram, and then as you can see by inspection, we have a triangle ABB. Okay, now you remember the theorem that says that the angle in a semicircle is a right angle, which is 90 degrees. So ABD is an angle, that is angle at D is an angle in a semicircle. So this particular angle here is 90 degrees. So we have ADB is equal to 90 degrees. And now what is the reason for that? We say angle in a semicircle. Angle in a semicircle is 90 degrees. So if this particular angle is 90 degrees, then we can now find angle at A. So angle at A plus angle at B plus angle at D is equal to 180 degrees. Okay, so let's proceed. So let's get the value of A. B is 52 degrees plus D 90 degrees equal to 180 degrees. So angle at A is equal to 180 minus the sum of these two is 142 degrees. So angle at A is equal to 38 degrees. So A is 38 degrees. So now to find Y, we say angle at A plus angle at C sum up to 180 degrees, and that is cyclic quad. Okay, we have a quadrilateral whose four vertices touch the circumference of the circle. So this angle, they are opposite to each other. So we can now find angle at Y. So this is cyclic quadrilateral. So angle at A is 38 degrees plus angle at C is Y equal to 180 degrees. Okay, so let's use the other side. Okay, so the value of Y is equal to 180 minus 38 degrees. 180 minus 38 degrees, so that will give us 142 degrees. So the value of Y is 142 degrees. So to find X, we can say that this triangle is an isosceles triangle, that is triangle BCD is an isosceles triangle. So we say that triangle BCD is isosceles. Okay, so that implies that the base angles of the triangles are equal. So we can also call here X. We can call that particular angle X. So let's proceed. So we have X plus 142 degrees, which is also the side Y. So sum up to 180 degrees. So we have 2x equal to 180 degrees minus 142 degrees. So 2x equal to 38 degrees. So divide both sides by 2. So x is equal to 19 degrees. Okay, so you can see that y is 142 degrees and x is 19 degrees. Thank you for watching. See you next time. Bye.